Okay, so let's take a look at the answers to the problem set. The first question here involves calculating inflation between these two sets of years. So what we need to do is to compute the percentage change from one year to the next. So for example, we're going to go on the first one here, 2017 to 2018. So we take the new CPI, which is 2018, minus the old CPI divided by the old CPI and multiply that by 100. So in 2018, we have 215.537. And then in 2017, we had 217.303. Divide that by 217.303. We're going to multiply that by 100 to get our answer. So I'm just going to take a look at my calculator here. 215.537 minus 217.303. That gives me a minus 1.766. And I'll divide that by 217.303. And that gives me a minus 0.008. If I multiply that by 100, that gives me a minus 0.8 in terms of inflation. So because this is a negative sign, that means inflation is actually going down, which is something we call deflation, which is the answer there to the second part of the question. What do you call what happened between 2017 and 2018? Because it's negative inflation, we call it deflation. There it is. We call it deflation. All right, so for the second part, this 2018 to 2019, we go through the same mathematical calculations. So we just put new numbers in there. So it's 219.056 minus 215.537 divided by 215.537. And then we'll multiply that by 100. So let's see, 219.056 minus 215.537 equals 3.519 divided by 215.537. That equals 0.016 multiplied by 100 gives me an inflation rate of 1.6%. In terms of in terms of rounding, if you went to 2 decimal points, that's fine. If you just went to 1 decimal point, that's fine as well. If you carried it out to 3 or 4 or 5, that's okay too. So as long as you're sort of in the ballpark here, we're looking at numbers at 1 or 2 or 3, 1 or 2 decimal points beyond, or 1 or 2 places beyond the decimal point is fine. And of course here we have inflation because prices are going up. So that's the first question. Let's take a look at the next one. The next one is a question having to do with aggregate demand and aggregate supply. So we're asked, the U.S. Congress is debating the use of personal income tax hikes to pay down the government's debt. Using a properly labeled aggregate demand and aggregate supply graph show what the model predicts will happen. Okay, so the first thing we need is a properly labeled aggregate demand, aggregate supply graph. So here we're going to have real GDP, and here we're going to have the price level. So let's put our model together. Here's the long run aggregate supply, and the short run aggregate supply, and here is aggregate demand. So the key for this question is that the Congress is debating the use of personal income tax hikes. Personal income tax affects your income. If personal income taxes rise, that means your income is going to fall, your spendable income goes down. And if your spendable income goes down, that means consumption is going to go down. And if consumption goes down, that means that aggregate demand is going to go down. So we need to draw that in. Here's our new aggregate demand curve. And now we compare the first equilibrium, we'll call this P1 and Y1. We compare that first equilibrium to the new equilibrium. And here we can see that output would fall. There would be less consumption. So that's our first question. What happens to output? Output goes down. The second question, you've got to pay attention to what you're being asked. You are asked about employment. So if output falls, that means you need fewer workers because you're producing less. So there will be more unemployment or less employment. Employment is what you are asked for here, so employment is going to go down. There will be fewer people working. And we also see changes in the price level. We go from P1 down to P2. So in this question, everything's going to fall. Output, employment, and the price level. All right, let's move on to question 3. Question 3 is dealing with something we talked about before, spring break. So you're going to have to go back a little ways on this one. In this question, we are asked to use the data to answer the following questions about Homer's Donuts. So we have a column for number of workers, a column for output, a column for total revenue, and a column for the value of the marginal product of labor. So here's the number of workers. Then we have output. And then we need to find total revenue and the value of the marginal product. So here's what we're looking at. Number of workers was 0 to 7. And output was given to us. So we have 0, 40, 70, 90, then 100, 105, 107, and 105. Now, what we need to do first is we need to figure out the total revenue. To get total revenue, we need to know what the price is. And in the first part of the question, or the first question under the table, you are told that the price is equal to $1. So, filling out this table with a price of $1 means that we just take the output, which is our quantity, times the price. So total revenue in the first column is going to be 0 when we have no output. Then it's 40 because the price is 1. We just take output times price. So 40 times 1, and then 70 times 1, and 90, and 100, and 105, 107, 105. Those are our total revenues. The value of the marginal product of labor requires a little additional step here. We need to figure out what's the marginal product of labor first. So I'm going to do that here. The marginal product is the change in output as we add a worker. So we go from an output of 0 to an output of 40. The marginal product of the first worker is 40. Then we go from an output of 40 to an output of 70. So the marginal product is 30. That's the change in total output. Then we go from 70 to 90. The marginal product is 20. 90 to 100. The marginal product is 10. Then 5. Then 2. And then -2. That's the marginal product. The value of the marginal product is the marginal product times the price. Now the price is $1, so this should make our math really quite simple. So here are our answers for the value of the marginal product. The value of the marginal product is 0 in the first line because there is no marginal product. And then it's 40, 30, 20, 10, 5, 2, and -2. We're just taking the marginal product times a price when the price is equal to 1. So that's what your table should look like. Now, in part B, you are asked if the price is $1, which it has been already, and the market wage is 8, how many workers will Homer hire? Well, if the wage is 8, you need to compare that wage to the value of the marginal product. So clearly this worker down here, you don't want to hire this person. The value of their marginal product is negative. That would make no sense. The 6th worker has a positive value of their marginal product, but if all they generate for your company is $2, they're not covering the wage. You need to compare the wage to the value of the marginal product. And if the wage is greater than or equal to the value of the marginal product, then you hire that person, which means the 5th worker, you don't hire them either because the value of the marginal product is below the wage. But this worker here, worker number 4, they're a yes, because they're generating more than it costs you to hire them. And surely you want to hire all these other workers too. So, assuming the price of $1 and the market wage of 8, how many workers do you hire? The correct answer here is 4. Now the other two parts of this question, part C and part D, they're basically the same question, but you have to change some of the numbers. So what happens if the price of donuts rises to $2? Well, if the price rises to $2, that changes the value of the marginal product. The value of the marginal product, and let's see if we can do this in a way that is not so messy that we can't see what's going on. Let's do this in kind of this purple color. The value of the marginal product when the price is equal to 2 is going to be double what it is now. So it's going to be 80 and 60. So again, this is when the price equals 2. So 80, 60, 40, 20, 10, 4, minus 4. That's the value of the marginal product. So in part C, we're looking for how many workers are we going to hire? Well, because they're selling the product at a higher price and the value of the marginal product rises, now we still don't hire this person. And we still don't hire the 6th worker. But this 5th worker is now worth hiring because they're earning 10 as opposed to what you're paying them, which is 8. Okay, now that gets us to part D. And in part D, we'll try to answer with this kind of turquoise. In part D, you're told that the price equals 1, but that the wage goes up. Now the wage is 15. So we're going to use this column right here. But now we, instead of using a wage of 8, in which we hired 4 workers, we're going to look at comparing this to the wage of 15. So basically what's happened, the minimum wage has gone up, or whatever the wage is. So we're still not going to hire this person. We're still not going to hire this person, and we're still not going to hire this person. At a wage of 15, we're not going to hire that fourth worker either. They're not covering their costs. We will hire the third worker because they are generating enough in terms of the value of their marginal product to cover their wage. So the correct answer for part D is we will hire 3 workers. All right. So let's move on to question number 4. Question number 4 is, it may seem complicated, but it's actually far less, there's far less going on here than what we saw in the question number 3. So here what we're looking for is, what's the real growth per person? What's this here for each of these 2 countries? Remember, our real growth per person, we just covered this topic this week. Real growth per person is equal to the nominal GDP minus inflation minus the population growth. So let's take a look at Valjean. In Valjean, the nominal GDP is 12%, inflation is 10%, and the population growth is 1.5%. You don't need to know the unemployment rate. That's not important for this question. So we take 12 minus 10. That gives us 2 minus 1.5 gives us a real GDP per person of 0.5%. That's our real growth rate. Now, the years that it's going to take GDP to double requires us to use the rule of 70. Remember, the rule of 70 tells us take 70 and divide that by your growth rate. Our growth rate is 0.5, so that's going to tell us the number of years it takes income to double, and 70 divided by 0.5 is 140. So, now the last part of our table asks, what's the real GDP per person in 140 years? So if Valjean starts off with 1,000, and GDP doubles in 140 years, then real GDP per person in Valjean in 140 years will be $2,000. Okay, now what about Kazakhstan? Well, we go through the same process here. In Kazakhstan, nominal GDP is a lot less than it was in Valjean. It's only 5%. Inflation is a lot less also. It's 2%. And the population growth rate is less. It's 1%, which means that the real GDP per person is growing at a rate of 5 minus 2, which is 3 minus 1, at 2%. That's real GDP per person in Kazakhstan. 2%. The years required for real GDP to double, we take 140 divided by 2%, which means that the real GDP will double in 70 years. Oops, sorry, back that up. That's 70 divided by 2, so real GDP is going to double in 35 years. 70 divided by 2. And so the last part of the question says, all right, what's real GDP per person in 140 years? We start off at 1,000. Income doubles in 35 years, which means income will be $2,000 in 35 years. But that's not what we are asked for. We are asked for what happens in 140 years. So we need to add another 35 years. So in 70 years, 35 plus 35 is 70, income doubles again to 4,000. But we're not to the end yet. In 105 years, which is another 35 years, income doubles again to 8,000. And then in 140 years, income is going to double one more time up to 16,000. So in 35 years, it doubles. In the next 35 years, it doubles. In the next 35 years, it doubles. And then in the next 35 years, which gets us to the 140 years, income doubles again. So income will be $16,000. All right. Some of you may have used a different formula for this, but you'll be pretty close. If you don't know the formula, the kind of the financial calculation formula, here's a simple way to go about that. Now, finally, we are at the last question, and the last question is talking about a group of concerned citizens in a small town. They're organized against fracking. Even though the fracking promises to increase employment, reduce energy, and I should say increase in energy independence, fracking involves potential pollution of the groundwater, truck traffic, loud drilling processes, and these are costs. Okay, so here's the first thing you want to pay attention to. These are costs expected to impact people who receive no benefit from the fracking activity. So you need to figure out one of the things, what have we talked about where there are costs imposed upon people who had no role in creating them and consequently received no benefits. That's the basis upon which you would answer this question. And those things we talked about as externalities. And specifically, this is a negative externality. So if you were to say there is a negative externality, you would be correct. And now all you need to do is draw the negative externality graph. This goes back to the pre-macro world. So we're not talking about aggregates here. We're talking about the specific market for energy. And if our market for energy was just based on the private interactions of people, where they did not have to worry about the externalities, then we would find ourselves at an equilibrium here. We'll just say Q1 and P1. But because of the external costs, the pollution of the groundwater, the increased truck traffic, the loud drilling, there are additional costs that have to be considered. There are those social costs. And if they are taken into account, in other words, if the producers have to bear those costs, then that's going to shift the supply curve back to the left, give us a lower amount of activity, not no activity, just less activity at a higher price. So that's the problem set. I'll get these graded and get your scores posted hopefully relatively quickly. And so you can use this as a review for the exam coming up.